Hey guys, Mr. Isaacs here. We're going to go into part 3 talking about the planets, the Earth, and kind of the physics behind how everything is rotating around us and a little bit of stars. So, Earth and space, here we go. Let's talk about the position of North America having winter and why. So, looking at A, B, C, and D, we are looking for winter and summer, the easiest ones to spot, because wherever the pole, we are looking at the North Pole is where the northern hemisphere is and where North America is. And so if it's facing away from the sun, it's got to be winter. If it's facing toward the sun, like position A, then it's going to be summer. All right. Then from there, you can decide which one's which based on the Earth is orbiting the sun counterclockwise. All right. So A to B, all right, is going to be summer, and it's headed toward winter, right? So summer to fall to winter to spring. Okay. So we should have when is winter in the northern hemisphere, it should be C, and then it should be D for the spring. Okay, because you're heading from winter to summer. Your days are getting longer. All right. At what position is it winter in Argentina? Argentina is in the southern hemisphere, so we flip it. Okay, so Argentina is the bottom here, and it's facing the sun. It's closer to the sun than if it was on the opposite end. Okay, what position is it winter in Argentina? Well, this would be summer, actually, whereas we actually want something closer to, if we're looking at this map, summer in Argentina would be C, and winter in Argentina would be A. So it's A. Okay, what would happen if the Earth, what would happen if the Earth's rotation speed increased? So it was spinning and making our days faster, actually. So the days would decrease. Let's see, where did our answer go? Clicking. Come on, people. Oh, we're up here. Okay. Which part of the Earth has the least amount of change in daylight hours and why? Okay. Which part of the Earth has the least amount of change in daylight hours? Well, that would be the equator. The equator is always going to receive the same amount of sunlight no matter where it is. Okay, it's going to be very, very similar no matter if it's summer, winter, spring, or fall. Okay, it's always going to have very, very similar. So the equator gets direct sunlight all year round. All right, name what season location A is having. Describe it in days. So location A, way up here on the opposite side, it's facing away from the sun, so it's got to be winter. Name the season location B is having. Describe its days and nights. Okay, B is going to have its longest days of the year because it's going to be summer in the southern hemisphere here because it's closest to the sun. All right, and then why is location A's season different from location's B's season? Well, it's because the pole is facing away for the northern hemisphere and the southern hemisphere is facing toward the sun. Okay, and so it's angled toward the sun, getting more, or angled away from the sun, getting less sunlight. All right, so you can kind of see how that goes. Summer days are longer, winter days are shorter. Okay, the Earth is tilted. The northern hemisphere is away, and the southern hemisphere is the opposite. Okay, now we can get to the rotation. The Earth's spin would be faster, and the length of our days would be shorter, okay, because it's rotating faster. Okay, what would happen if the Earth's revolution speed increased? So this is around the sun now. Okay, if that increased, then our years would be shorter. Okay, the length of the year would be shorter because it would travel around the sun faster. Okay, a student using a globe to model day and night. What else does a student need to add to this model to correctly show day and night? Well, knowing where your light source is would really help for day and night. What is the cause of the Earth's seasons? Well, it's the tilt of the Earth. Okay, so where's your light source? Okay, and then the Earth's tilt. Here we go. Talking about the moon, everybody's favorite unit. All right, so we're talking about waxing, waning, a gibbous, crescent, new, full, and quarter moon. This all happens within 28 days. All right, and so you're able to see a change every 3.5 days. Here we go. So waxing, you wax on, you wane off. Okay, so light on the right, glowing, growing larger. Okay, light on the right, growing larger. So it starts on the right side of the moon, and it's going to get bigger. Okay, so is this your right side? It's kind of mirrored in my picture, but I'll start on your right side. Okay, and it's going to get bigger and then the darkness will take over. All right, so waning is going to be light on the left, growing smaller. A gibbous is more than 50%. You can see it. Okay, so it's where you see 3/4 of the light. Crescent is when you see 1/4 of the light. Okay, or less than 50%. New is you don't see the moon at all, and full is you see it completely. Quarter is exactly in the middle, a quarter moon. It looks like 50% of the moon, but it's actually called a quarter moon. Okay, so let's see here. So we start with light on the right, and it's going to grow. So we got waxing crescent. Okay, this is going to be a quarter, first quarter. We have our gibbous, okay, and so it's still waxing, so it's a waxing gibbous. We're going to have full moon. Now we're going to have a waning gibbous, is what you would have up there, okay, at the very top. A waning gibbous, because we'd have the darkness coming in from the right now. Then we'd have a third quarter moon. Then we'd have a crescent, a waning crescent, and then new moon. All right, so that would be all of our things. If May 4th, the moon phase is first quarter, what will be the date before the next new moon? Okay, so we start with first quarter. Remember, every 3.5 days, you get the next one. So we're looking for the next new moon. So every 2 of these sections is a week. So full moon would be in a week. Then we'd have, in another week, we'd have third quarter. And then we'd have another week, we'd have a new moon. So you can expect, if we're looking at the 4th, it should be 3 weeks, the 11th, 18th, the 25th. So it should be the 25th. So full moon would be 4th quarter, new moon should be the 25th, okay? Remember, every 3.5 days is going to be a section, and every week is going to be 2 of those sections. Okay, draw the moon to indicate when a new moon is visible from Earth. Okay, that's funny because new moon means you can't see it, okay? And it means there's no sunlight on it. So it's actually when the moon's in between the sun and the Earth, because the sunlight is coming here and is blocked by the moon, and so the moon is lit up on the side that we can't see. Okay, name the moon phases in these positions. All right, so you just really got to think 3D. Okay, where's our sun coming from? The moon's always going to be lit up on the left side, but you need to think of your perspective from Earth, what you're actually seeing. So here, if you're looking at this moon, the right side of the moon is barely going to be lit up. Okay, so if there's light on the right, it is growing larger. Okay, so this is a waxing crescent. Okay, this is going to be a waxing gibbous. Now the darkness is on the right. All right, so now we got a waning gibbous and a waning crescent. Okay, the moon is between the sun and the Earth. Waxing crescent, waxing gibbous, waning waning crescent. All right. What is the greatest effect of the ocean tides? Okay, so the largest effect, or high tide, is going to be when we have a new moon and a full moon, because it lines up with the sun's gravity and they add to each other. Okay, and so what happens is they both are pulling on the Earth's oceans, and they're going to pull them higher. Okay, whereas third quarter and first quarter moon, they're pulling against or in a perpendicular direction from the sun, and so they're not going to pull as high as you could otherwise. So when do they have the greatest effect? Oop, shouldn't have moved there. What is the greatest effect on the ocean tides? Well, the moon's gravity is that answer. Okay, during the moon phase, do neap tides occur? It'd be first and third quarter. So this bottom one, first and third quarter. Neap tides are when they're pretty consistent all the way around. There's not really a difference between high tide and low tide, whereas the spring tides, when they're big, that means new moon and full moon are happening. Okay, draw the correct positions of the moon that has the greatest effect on the ocean tides. Well, it's going to be our spring tides. So it's when it's new or full. Okay, let's keep going. Oh, I love stars so much. So what is a nebula? Nebula is just a ball of gases that is eventually, if it's large enough, going to form a star. Okay, collection of gas. It's the result of it's how you form new stars. It's a result of some dying stars. Okay, what is a galaxy? It's a cluster of millions of stars. Okay, a collection of millions or billions of stars. Okay, held together by gravity, usually supermassive black holes in the middle to hold the whole thing in place. Okay, what is a star? Well, it's a sphere of matter with density and temperature great enough to cause a nuclear reaction at its center. Okay, nuclear fission is going to be happening, and so it's going to heat up those gases, ignite them, and burn them very, very, very hot. And it will burn for a certain amount of time. Okay, in the class G, what group of stars are the brightest? So you got to use your skills here, find G. You got to come up here, and then you got to realize luminosity is brightness. So the higher you go, the brighter they are. So we have red giants. Should we choose that? Nope. We should go all the way to super giants because these are going to be the brightest. Okay, so what class of stars? Okay, it should be super giants. List the following objects in order based on the size and mass from the smallest to greatest. Galaxy, star, planets, nebula, universe, comets. List the objects in order based on size and mass. Okay, so we have a bunch of options. Galaxies huge. Stars make up galaxies. Planets are way smaller than stars. Nebulas are pretty big. They'd be bigger than planets. Okay, the universe is the biggest of all, and comets are usually going to be smaller than planets. So let's see if we get it right. So comets to planet to star. Nebula is going to be bigger than stars, okay, because they're wider. Once those nebulas pull and organize that gravity and ignite the stars, then you're going to be able to form a star, okay? Galaxy, universe, all right? What type of galaxy? Well, we have irregular shape, we have spiral, and we have elliptical, okay? Spiral is the one that we're going to be most familiar with, that we've seen the most. Okay, describe Bernard star temperature and brightness. Okay, so you just got to look on your map here. You got to look for Bernard star. Here it is, right here. Where's the temperature? So increasing surface temperature goes to the left, and brightness goes up. So it's actually a very cool star and also a not very bright star. Okay, low temperature, low brightness. Describe white dwarf's temperature and brightness. Okay, white dwarfs are pretty bright. Remember, they're in this pool, so they're actually pretty hot, but they're not very bright because they're not very massive. Okay, so high temperature, low brightness. Compare the temperature and brightness of Spica to Procyon b. Okay, well, let's find Spica. Spica is going to be way up here, and then Procyon b is, if we can find it, Procyon A is here, and Procyon B is way down here. So Procyon B is pretty, it's not very bright, and it's a medium temperature, whereas Spica is super bright and super big. So very hot and very big. B is not very hot and pretty dim. All right, so there's a big difference there. The sun is a star in the Milky Way galaxy amongst billions of others. Where is the Milky Way galaxy? Is our star, where is it located? Okay, what's the color of the sun? Well, it's a yellow star. So that's where the sun is located on our map. All right, on Orion's arm near the outer edge of the galaxy. So we're way out from the middle. Okay, it's a yellow star. What's the temperature of the sun? It's pretty average. Okay, what's the size of the sun? It's pretty average to small. And then what is the brightness of the sun? Again, it's pretty average. Our sun's pretty average. It's pretty cool because it keeps us alive, but it's pretty average all the way around. Okay, our star, the sun, is an average size star with average brightness. There's many more stars that are much bigger, brighter than our sun, yet the sun appears so much bigger and brighter than any other stars. Why? Because it's so close to us. It's so close. Okay, and so it impacts us. Distance is a huge indicator of how that sunlight, those photons, are going to actually affect us. Okay, so it appears much bigger because it's so much closer than anything else. Why does Earth get so much more energy from the sun than other stars? Again, because of proximity, okay? Because it's so much closer to the Earth than any other star, okay? Spiral shape from top view, dish shape from the side, okay? Oh, baby, we got electromagnetic spectrum. We're talking about waves. This is pretty cool too. So we have wavelength is the distance between the peaks. Frequency is how quickly those wavelengths happen. The shorter the wavelength, the faster the frequency. Okay, more frequency, more energy. Less frequency, so more spread out. Less frequency, less energy. Okay, because if you think of waves on a beach, if they're high frequency, they're hitting constantly all the time. Okay, lots of energy. If they're hitting very slowly every couple of seconds or minutes, okay, not as much energy. All right, so there's a quick review of what's going on. All right, let's go. By studying the light from stars and distant galaxies, scientists know the objects in the universe are moving what? Okay, how far apart? We just talked about that. How many? Okay, yeah, okay. Because, so we know that everything's moving away from us. All the galaxies outside our local group generate light, and because it's in the red spectrum, okay, we can tell that it's moving away from us. Okay, we can tell that it's moving away from us. All galaxies outside the local group generate light towards the red end of the spectrum. Okay, do gamma rays and X-rays penetrate Earth's atmosphere? No, they do not. Luckily, we're protected by that. What is the approximate size of ultraviolet radiation wavelengths? It's the size of molecules. It's so tiny, you guys. Okay, an object in space is emitting a frequency of 1.4 to the 9th hertz, which is a frequency. The astronomer would most likely be using a telescope that deflects what type of frequency? The microwaves. Because if you look where microwaves are, if you look at 10 to the 9th, okay, we go right here, 10 to the 9th, in between 8 and 12, it's about right here. That's right where the microwaves are. So you want to deflect the microwaves because you don't want them to show up in your lens. What is a longer wavelength than infrared? Okay, well, let's find infrared. Infrared's around 10 to the negative 5th. Okay, it's right here. So what has a longer wavelength? Well, longer would be to the left, so less energy than infrared. You would have things like radio waves. X-rays would be more energy. Gamma, visible light would all have more energy. What type of radiation has a temperature of 10,000 Kelvin? Okay, so that's just really high temperature. Kelvin is what scientists use to measure temperature. So radiation temperature, okay, we got our 10 million Kelvin, 10,000 Kelvin. Looks like we are right in the visible light spectrum, so visible light. Okay, when you're moving away from something, you have red shift, but if something's moving toward you, you have blue shift. Okay, and that's because if you look, red is on the left and blue is on the right in the visible spectrum. And so when waves are traveling at you, you actually see them at a higher frequency, and so they look more blue because those waves get pushed closer and closer and closer together. But if it's traveling away from you, you lose frequency, and so it pushes it back to look more red. Okay, and so that's how we can see red and blue shift. All right, we're almost done. Hang in there. Okay, what crustal features formed at these types of convergent boundaries? Continental. Okay, so continental moving away, that's got to be divergent. Okay, folded mountains would be your answer here. Whereas ocean continental, you can see they're moving into each other. So you have an ocean plate moving into a terrestrial plate, and so the ocean plate's going to go underneath and form volcanoes underneath. Okay, so mountains and volcanoes you can see on the whole western side of South America. You get volcanoes and mountains. Okay, and then this is what is going to be formed. Okay, and then lastly down here, volcanic island chains and trenches. It's hard to see, but volcanic island chains, this is going to be from hot spots. Island chains and then trenches would be when ocean are moving away from each other as well. Okay, so let's keep going. Oh, I clicked a few forward. Mid-ocean ridges are shown in the image. as scars in the ocean. Draw the motion of the plates that create at these mid-ocean ridges. Name the type of boundary. This is when two oceans are moving apart, okay, and new land is being formed. Mountains are formed when you have two terrestrial plates going toward one another. We call this convergent boundaries, okay, because they're headed toward one another. Divergent is away, all right? The plate pulls apart at divergent boundaries, okay, so pulling apart at two terrestrial plates. Okay, these images are of the San Andreas Fault in California. Name this type of boundary. This is, and then draw the motion arrow. Okay, so San Andreas Fault is one that's headed up and down and not toward or away from one another. This is called a transform boundary, and it's going to create a lot more earthquakes, okay? So there, you can see those angles right there. Boom, boom. Okay, what is the area shown above called, and what type of plate boundary is created in this area where the world's most volcanic activity? So it's the Ring of Fire, is what we call it in the Pacific Ocean here. And basically this ocean plate is moving. There's multiple ocean plates here. They're all moving into the land, creating a lot of lava once it goes underneath the terrestrial plate and starts to melt underneath. All right. So the Ring of Fire boundary type is convergent. All right. Explain what would happen to the shipping channel if maintenance dredging did not occur. Okay. Maintenance dredging basically means that you're going to make it deeper. It would become too shallow for boats to pass. What effect is the fire most likely going to have on the river? More sediment will flow into the river because the fire destroyed the vegetation. Okay. And so you'd have a lot of organic material going into the river. Okay, what location around San Francisco Bay is most likely going to experience the greatest effect from wave erosion, and why? Well, it should be C because it's closest to the ocean. Okay, and that's actually going to experience all the waves. Okay, what most likely causes the sand dune changing shape over time? It's got to be the wind because rain is not as popular there. Okay, topography, everyone's favorite, all these little lines. Okay, remember, the lines that are connected are the same height. Okay, and then you need to find one of those bolded lines that tells you the height, and then you need to find the scale. So between every line is 5, 10, 15,000, 1 million, however, whatever the difference is between each line. Okay, each bold line, you divide that by 5, boom, now you're able to figure out the height of any area. So what's the difference in elevation between Warren Peak and the small peak marked X on the map? So Warren Peak is over here. Okay, Warren Peak looks like it's going to be 9,710, and the X over here looks like 8,778. Okay, so you're just going to have to subtract 932 feet. Okay, the peak over here on the X is actually going to be smaller. Okay, two hikers decide to hike the Sierra Blanca Peak. The hikers starting point were labeled A and B. For the hiker that took the steepest path to the Sierra Blanca Peak, what was their change in elevation? So A and B. A is the steepest by far because the lines are closer together, whereas B was not very steep because the lines are further away. And that's what you're kind of looking for here, all right? And then you can make comparisons and figure out, okay, A is on this line, it's 11,200, and B is 1, 2, 3 things below 11,200. Okay, so you know it's got to be smaller. Okay, so they over time they went a longer distance at a slower change in elevation. Okay, just showing this map on the right. This would be what the mountain would look like, and this is how you'd show it, because you'd show the steepness of this top peak, and then you'd show less steep here at the other peak. All right, we're almost done. Okay, look at the model above. How is this model different from the atmosphere and ocean convection currents? Okay, so the source of energy that drives the convection currents in the atmosphere and ocean is the sun. And so instead of coming from the bottom, it actually comes from the top, is where we get our convection currents being built from. Okay, the major patterns of movement of air and water on Earth are a result of convection currents caused by the uneven heating of the Earth. Okay, so because we change seasons, because the Earth is tilted, because we get different amounts of sunlight at different parts of the Earth, we have uneven heating, and we have to account for that. All right, and so that changes where the air is going. Okay, illustration shows unusual wind pattern at the shore during day and night. What is the most important factor that creates these wind patterns? Okay, it's going to be temperature change. Uneven heating of the earth, once again, is the result. All right, what is the name of this front and what type of weather is associated with it? It's a stationary front. It's got both of them, and it's kind of stuck in where it's at. A cold front is going to have the blue sharp icicles is what I think they look like. Cold fronts, rain and thunderstorms at the line. Then cooler, drier air from the frontal passage. Okay, what is the purple one where they're both headed in the same direction? Okay, this is an occluded front. Severe snowstorms in the northeastern United States are what this comes from. And then this is going to be a warm front when you just have the red. All right, what does the L stands for? It stands for low pressure. Okay, it's usually going to be stormy weather. And then high pressure systems are going to get rid of that stormy weather, usually clear skies. Okay, what state is going to experience cooler temperatures in the next 24 hours? Okay, so what you want, cooler temperatures. So the next 24 hours, it should be North Carolina, Florida. If you have options here, none of those work for us. So that means we're looking at Nevada would be a really good answer because they're this cold front. Okay, so I would go with Nevada. That's what I would say. What state will have completely clear skies in the next 24 hours? Okay, we want high pressure is going to be clear skies. High is always moving to low, so we're headed this way. So over Texas would work. Kansas would be another okay answer, but Texas should be our answer. Boom, money. Good job. Okay, hurricanes are more common on the east coast of the United States by Florida instead of the west coast by California. What is the reasoning behind the occurrence? It's because of this dry air that comes off of Africa around the Saharan desert. Is going to pick up steam and be mixed with the warm, wet waters of the Atlantic Ocean, and then it's going to gain power once it reaches the Gulf of Mexico, where we have the warmest water. Okay, when low pressure, so let's see if it says, yep, Gulf Stream is a warm current, and it's going to get its air from Mexico. When a low pressure system forms over the ocean and is fueled by mostly warm air, where on the globe would these storms intensify the most? Well, the equatorial region, okay, is where it's hottest. All right, so anywhere around the equator. What reduces the strength of hurricanes? Cold water definitely helps. Okay, and then what strengthens hurricanes? Well, warm and moist water. Okay, how could agriculture point C affect the rest of the area? Redstone villages, okay, are going to be right here. Affect the rest of the area. Okay, pollutants could be running into this area and down into our watershed. The reasoning is it's going to percolate through the ground and go into our water system, where then we ingest it. Okay, how do human activities on the surface affect groundwater supply? Well, all of our activities, eventually when it rains, the water picks up our toxins and puts it somewhere else. List ways that water soaks, percolates, seeps, filters, absorbs, all these good things. Thank you for your help. Good job today, and I'll see you guys in the next one.